the Social Computer Vision in Production webinar. You'll notice at this event we have Rachel Roberts, who's going to be joining us live in video. She's going to be our sign language interpreter. My name is Anthony Kelly, and I'm a principal recruitment consultant for computer vision with Trust and Soda. I'm the host of the Computer Vision in Production podcast series and the Soda Social webinar series, Computer Vision in Production. To get all the updates on webinars, podcasts, and events, make sure we're connected on LinkedIn. Make sure you're a member of the Soda Social meetup group, and then also that you're following Trust and Soda on LinkedIn. So around computer vision, it's been one of the very first areas of AI technology. It's been around even before NLP. Particularly around recent advancements have seen computer vision become more on the market. Developments on edge computing, high quality cameras becoming more available, have really changed how computer vision has been done over the last 2 and 3 years. And it's resulted in companies being founded across the world which have got computer vision at the core of their product, which 5 years ago, it just wasn't a thing. I was watching a Netflix show called The Social Dilemma a couple of weeks back, and it kind of brought me thinking to how the social media has actually helped with driving computer vision technologies through edge computing and cheaper high quality cameras. So I'm not sure if it's something a lot of people know, but if you watch The Social Dilemma, you can see how since social media has come out and been available on mobile phones, no other technology has seen such an increase and advancement in the technology that's available to them, such as mobile phones. And that comes down to 2 core technologies that are at the core of computer vision, being computing power and cameras. So I guess, look, if we can all agree on one thing, we can agree that social media has been good for one thing, and that's driving technology advancements that have been at the core of computer vision. So I suppose moving on to tonight's event, I'm joined by 4 great panelists, and each has their own unique story to tell about how they're using computer vision in production. So we've got Juta from ML6. Juta holds a master's degree in computer science. She's done ML6 in 2017, and she's currently part of their computer vision chapter. And we've also got Laura. Laura also holds a computer science degree with a focus on machine learning. She is the head of machine learning and computer vision at KickID. And then we've got Stefan. Stefan holds a PhD in physics. He comes from a software engineering background, moving towards ADAS, and now he is the managing director of specialised.AI. And then we've got Adam, who's the CTO and co-founder of Motor.AI. Motor.AI invents a system that enables AI intelligence to make safe decisions in real time, at the moment being applied to the mobility industry. So everyone, thank you for making yourself available to be a guest panelist. And I suppose, look, if we start off with maybe Juta, do you want to give a little introduction to yourself, your company, and how you are actually applying computer vision in production?
Yes, all right. Hello, everyone. Thanks, Anthony, for the introduction. So my name is Juta Staes. I work at ML6, and ML6 is a consultancy company in machine learning. We actually are not specialized in computer vision, so we have applications in NLP and other domains of machine learning as well. But we do have a lot of use cases in computer vision. We also have a chapter that tries to group all this information, and we do some research there as well. So one of the examples that we do a lot of object detection use cases, for example, people counting, and then we also track the people, of course, so more than just object detection. We have some use cases also just in image classification, so those still are very relevant as well. And I also worked last year on ML in production use case that worked with GANs that hopefully I will tell more about later. You're muted, Anthony.
Yeah, that's something you don't hear every day. So Adam, do you want to jump on next? Tell us a little bit more about yourself, Motor.AI, and the applications you have with computer vision in production.
Yeah, so we at Motor.AI, we're a Berlin-based company. We're 3 years old. We're working in autonomous driving. And although like on the decision-making side of things, we use cognitive AI or cognitive computing, We also do a lot of work with computer vision, both with some conventional technologies and then also with artificial intelligence, deep learning technologies, and new explainable AI techniques, because our big focus is to build a certifiable system, so a system that'll meet ISO standards in terms of safety, because of course with autonomous driving, you need to get a lot of public buy-in that it's a safe system. So that's sort of our focus.
Excellent. Laura, same question to you.
Yeah, sure. KickID actually offers a digital performance evaluation for soccer players. So we are solely focused on that. And we set up and track test games and measure a whole host of performance critical factors during a game, such as passes and speed. And then our analysis, which is built on the knowledge of our soccer experts, computes a score for each out of these values, which is the so-called KickID. Yeah, and the score and further sub-scores allow the players to compare themselves to other players and also to former performances. And one specific goal we have is to make KickID available for everyone, so especially for younger players, to help them on their path maybe to a career in soccer. And for us, this means that our system needs to have low costs and must be easy to use. And yeah, computer vision is a big part to reach that goal.
Excellent, excellent. So Stefan, are you with us?
Yes, I'm here. Sorry, I had to reconnect. Sorry.
No
My name is Stefan. I'm the co-founder and also managing director of SpleenLab. I worked more than 8 years for top tier ones in the automotive industry in driver assistance research, in deep learning based systems. And what I really took with me was the message that there is no system that could be certified yet, which is really composed by typical technique, what we call today AI, mostly deep learning, CNNs, and all that stuff from the computer vision thing. So what we do at SpleenLab, we build systems that react in real time and perception, localization, and also planning and control for three typical markets: aviation, automated driving, and also the UAV industry. We try to tackle here the certification standards because we want to do it safe, not safe from an objective point of view, really safe from a certification point of view. We have really two unique designs, right? This is safety by design and a data bootstrapping technique, really to scale our labels. And yeah, this is our technique, pretty similar to what Adam told. But we do it for UAVs. We have here SORA. We do it for aviation. We have the D0178, and we do it for automated driving with ISO 26262 and ISO 21448. So yeah, and that's what we do.
Excellent, excellent. So prior to us having the live session today, we've been talking about topics that kind of align with everyone, and I suppose one thing that we've all sort of looked at is situations that startups feel. One thing I've already mentioned is that, you know, companies are now starting to have a focus on computer vision. Some companies have computer vision teams within them. So, you know, you're kind of reaching these situations where I suppose what's whose role, what's what. Do you get to a stage where you just throw data over the wall and the other guy's supposed to deal with it? Or do you get people to manage the end-to-end process? So, you know, it's kind of having specialized employees. It's not like the Henry Ford production line model. It's more of an all hands on deck. But I suppose, look, from dealing with these situations, you can face potential production issues, you can face potential motivation issues. So look, if we maybe start off with you, Adam, what's your kind of experience in this situation about not having specialized employees? How do you communicate it with your team, or how do you distribute the work to ensure that you can get an end-to-end model in production successfully?
Right. No, it's a real challenge because generally speaking, like the computer scientists who come out of the AI programs, they're really good with the machine learning, but they don't necessarily have, like, let's say, the DevOps or the backend background often to pull off the end-to-end system. On the other hand, we've also found that it's really, really useful to try to build up sort of a research and development team where you try to really encourage the creative thinking, because a part of the challenge with computer vision is often that the results that you can easily find, or in terms of like the models that you can easily find, the ideas that you can easily get, they're not necessarily good enough. And so you need to try to invent something new. And so you're always challenging yourself, and potentially you're even throwing away work. And so you need a type of engineer who is creative, willing to be challenged, willing also to like sort of be a real scientist in the sense of like parting with an idea if the data doesn't, pan out. But on the other hand, you need the production side. So we try to sort of build up sort of a production team and then sort of the research and development team. Of course, right now we're still relatively small, so there's a lot of overlap between those two, but that's the path that we're going down. Because the production guys have to focus a little bit more on, the quality, reliability of the code, the loop, the infrastructure, as you talked about, but a little bit less on just like the creative problem solving at the AI level.
Excellent. Laura, if we go to you, the same question: how are you dealing with similar challenges? How are you setting up, even prior to development, to sort of deal with these scenarios?
Yeah, Adam said it quite well. You do need a specialized research team for complicated topics. And we do have such a topic. So we do have a dedicated machine learning and computer vision team. But since we're a small company, it's a small team, and we don't have large teams for the other departments. So we don't have a large front-end or infrastructure team. So it's still all hands on deck, as you said. So we still have to help each other out and understand the fields of other people around us. We have to work together and have to, especially manage all the interfaces our fields have. And it goes without saying that we have to learn what other people around us do. And I think, but I think sharing those responsibilities can be really helpful and can help us improve our teamwork and expand our horizons. So I do like it.
Excellent. Stefan, if I aim the same question at you.
Yeah, I am also convinced that we need a heterogeneous team, a team which is really composed by people who have different advantages, disadvantages. But what I really experienced that is we have some robotics, some electrical engineers guys, we have some deep scientists focusing on machine learning, and also really deep on computer vision. So we have an extreme heterogeneous team. So we work in an agile environment, and we see people challenging each other, and it's really good to see that we can make progress in this direction. So AI at its all is a really complex field, and we have to keep our eyes open, because the open source community is pushing so far. So this is really something where we have the feeling, okay, we cannot do everything on our own. So we use as well for POCs, we use ROS and all that stuff, right? This is really, from my point of view, really important. On the other hand, I see it's also really important because it's such a big field, really, to cooperate with different companies. That's what we do a lot. If we go to projects, we try really to put really advantages or some core USPs one company has to combine with other company, and then we can put together the AI skills and the production skills. But in our company itself, most people come from strong dev background. So we have a strong CI, a strong build server, we have a strong process in that direction. We focus more on that because we are also going embedded in all that stuff. So AI comes as a bonus, but if someone is really skilled in all the dev things like computer science, Git, Garand, all what you all know from the continuous integration pipeline, then it has more opportunities for us to hire such guys than the best skilled AI expert. So this is thing we really observed. But I really agree to the others. That's the thing, or the thing I experienced here. And what I also can say that it's always good to collaborate with universities to keep really attached to local groups focusing on machine learning, exchange ideas. It's always good to get then new people and keep contacted, and then also stay on the cutting edge, right, of the AI technology, because it's so much progress. So I come from physics, so I saw there was not so much progress in the field like in the new AI technology, and I see here we have to really keep eyes open and stay in contact with the machine learning groups and collaborate with other companies. This is the thing I observed, but it's my personal idea.
Thank you, Stefan. And Juta, same question for you. How are you kind of balancing out the tasks? I know you guys are probably, it might be funny to hear, but you are probably the biggest company out of everyone who's involved here.
Right. So yes, at ML6, I think we have a
team
of.
Sorry, Judy, your sound has kind of gone quite low.
Yes. So I'm really sorry for this, but I changed my microphone and it's low battery, so it's charging. So maybe we can. Yeah, I want to answer if it's feasible like this or.
It's pretty difficult, but when you lean forward, I think maybe if you speak into the mic more specifically, that was.
Yeah, I will change back to my other headsets in a minute, but I will do it like this. Okay, so we have a team of 40 engineers. So most of them are ML engineers, and actually most of the people that start at ML6, they start as ML engineers, and then kind of they specialize each in their own fields. So we have some people. First of all, we have the different fields: computer vision, NLP, etc.
I think we're kind of losing you. Juta, do you think we can kind of, can you use your headset, or could we come back to you in a few minutes?
You can come back to me in a few minutes. Sorry.
Cool. No problem. So I suppose the question then that I wanted to ask Stefan, Adam, and Laura, whichever one of you wants to jump up and answer this first. Particularly even you, Adam, you mentioned there's a lot of these great candidates, great talents that come out from these deep learning computer vision courses, but they're lacking, maybe without saying it, but the fundamentals of deployment of and bringing algorithms into production. But when they come into these positions, if they want to join a startup company, they'll be bright-eyed, bushy-tails. They'll be thinking, I want to build models, don't want to work on deployment because I'm a data scientist, not a software engineer. How do you set those expectations to someone who has that sort of ideology about what a position should look like?
Yeah, well, I mean, for starters, without like naming names, I've seen some like open source like deep learning repositories, which are really good in terms of the results. But if you just look at like the coding standards, it wouldn't pass like your regular sort of junior programmer review, like functions that are 1,000 lines long and that sort of stuff. So we sort of start a little bit at the basics in terms of coding practices that we adhere to even for the models. So then like you usually start out with some, if we hire a machine learning heavy candidate, then they start out with a machine learning AI task. But we slowly try to get them used to this idea of, okay, fine, you have to like learn some the coding standards that are required, and then we have our own process for our own sort of existing like deployment loop and getting them used to doing like code reviews and that stuff. So it's really, we don't throw people in at the deep end. We sort of acculture them to it over some time. And in the cases where then it's necessary for them to learn, I've often found that the people on our team, they're just really, they're problem solvers. And so if they need to learn a little bit about, let's say, like how AWS works so that they can, you know, better build up the pipeline, then they can do that. And then we can also support them there. Yeah. And then like finally, the last point is with some of the tasks that are often in the pipeline, like the annotation or the training, we've tried to automate that as much as we can. So there we then try to explain in-house, like what are the automation steps that we've done? How does that work? But that's a little bit our attempt to like save everyone's time as opposed to just getting everyone up to a certain proficiency of, let's say, like the continuous integration loop.
Nice, nice. Stefan, Laura, would you like to jump in with something on that?
Yeah, again, Adam said it very well, but yeah, I usually like to have people start with their own little project where they can really, first of all, try out what they know and what they don't know and try to make mistakes. Just make mistakes without fearing critique. Of course, then I sit down with them and evaluate what happened and where there may be some lacking in skills, so we can train on that. And then they can slowly start to work together with others and build bigger projects, but they just started to make a project from start to end on their own, and that I think helps learning the pipeline and all the steps that are involved, like building a data set, learning what a good data set actually is, which is, I think, a very important part. And yeah, another big part is learning actual computer science, which is often a problem, as Adam said. So we often just do lectures and talks about basics in computer science, especially for non-computer science people. And I think that helps a lot.
Excellent, excellent. Stefan, do you want to answer, or do you want to move on to the next one? Do you think we covered?
No, just I can answer, but I guess most of the thing is set. So we are more robotics company. So there's AI is more or less embedded computing. So computer science is the core competency, and what we typically do with people in a quiz, we try for really small algorithm, pure review process and all that stuff, and see how the skills are. And mainly we not focusing on really on AI scientists or really people who treat themselves as AI scientists far away from embedded computing. So we really focus on people who come more from computing side. Since we're doing this safe AI thing, we're doing everything around. Most of our customers only want to do the deep learning algorithm. We do the things around and make that safe to the certification standards. And this is what we do. So we really focus on strong computer science people, but they come from most of the domains.
Okay, cool. So trying to keep us within time, I'll move on to the next one. So another challenge that a lot of startup companies can face is finding investment, and it's one thing that even I've done a good bit of research into, and it's deep tech VCs calling themselves deep tech without actually understanding what computer vision is. They might see one or two big players, maybe in Berlin, one or two players in Munich, and they kind of think, you know, I want a piece of that action. Everyone else, I'm not so interested in. You know, how are you presenting yourself? How are you speaking with these VCs to help them understand what it is you're doing? Because essentially, computer vision, the topics that's happening now are cutting edge. They've not been possible 2-3 years ago since recent developments. So if you're not in the field, you're kind of in disbelief that it's actually happening, right? Who would like to take that one first?
I could dive in. I mean, I'm also very interested to hear everyone else's points, and particularly Stefan, because he's also already mentioned the magic words 21448 and probably ISO 26262. So I'll be interested to hear his take. We've really run the gamut over like the last 3 years. Our pitches have been changing all the time. I think only like in the last month and a half have they kind of like stabilized, and the pitch deck that I've got now is the same that it was in September. We started out really just explaining the technology. We found that that often lost investors that we were talking to here. They just they wanted to see more sort of the product of the application. They first off sometimes didn't understand what was unique about the technology. Then for us in particular, because in autonomous driving you have a lot of marketing going on, which is always, you know, you just have to check Elon Musk's Twitter account to get the latest prediction on when it's going to happen. There's a lot of marketing, and the general feeling it's either one day, oh, it's coming in a year, in which case, why should I invest in a startup? Because they'll just be like out of business because VW or Tesla will roll out in a year, or else it's going to come in 50 years or something like that, in which case, why should I invest in a startup now? Because it's such a long time horizon. And we first took the tack of like trying to educate people about the certification topics and how that impacts autonomous driving here inside of Europe and also parts of Asia. And lately we found that we actually have to explain a lot more also about the product. So like, how are we going to use this technology to actually make money? Because inside of Europe, the investors still want to see that you can make a return on investment on the deal. So I've seen some US pitch decks where they're just very technology heavy and just really sort of selling a vision in a way, but I haven't seen that that works here. So I'll just stop there and let the others take over.
Cool. Anyone else want to jump in on that one?
Yeah, I just want to underline this. So I also we had luck that we finished one late seed round last year, and this was a very strong way in that direction, because we also started with a very technology deck, right? Really with simply a system architecture of a full autonomy approach, and no one had the idea. So we changed that, design more bootstrapping single modules with revenue in short term. This was then interesting for all people, and also getting first POCs with big players or big names is also very, very important. So it's not focusing that much on the technology. Also, everyone is throwing out the AI technology, and everyone is really interested, but had over 100 talks with VCs and more or less always the same answer. So how much revenue, when will it start really with revenue, and this is too low, and oh no, this is exactly the same was what Adam said. So we started, that's why a little bit, because of the autonomous driving and the big competition, we started more with the avionics and the UAVs, because we feel that here is a short-term market, especially in the UAV. So there's also some certification standard SORA, and there's everything changing every day, but they want to fly autonomous, no one can do that yet, or according to certification standard. That's why we shifted a little in that direction, our deck, because we saw, okay, the competition is a little less there. But at the end of the day, here in Europe, or especially in the DACH region, so it was really focusing on the revenue, not that deep on the technology. But at the end, we found some VCs really focused on the technology and technology driven, but it was a long way, and we had to have lots of talks, and this was really, we have to have a strong consistency and endurance on that.
Nice. Laura, Juta, would you like to weigh in on that, or? No? Okay, cool. So the next and final topic, I suppose, around startups is one, finding the right candidate, but not so much just finding the right talent, more so the cost versus time. So you always have two options. You can hire someone who's highly specialized, hope that they fit in well, and hope that the hire is a success, versus time is you're spending more time with someone, hiring someone maybe more junior or mid-level, and bringing them in So I suppose it really depends on what you're willing to commit to as a business or what you're looking for. But I suppose when it comes to making these sort of decisions, I suppose what do you consider? And if we start off with you, Laura, like what comes into your head when you're thinking the recruitment faction, cost versus time?
That's definitely a problem for us as a small company, as a startup. So on the one hand, we don't have the money or the prestige to be competitive with bigger companies. We're not competitive with Google, obviously. And on the other hand, we don't have the resources to teach people to invest in the long run into many people. So we have to make a start in building a team. I think we do have one really important advantage, and that's soccer. So we can grab people that are interested in soccer, that have a passion for soccer, even if we maybe can't be competitive in the salary. So yeah, one of my very, very valued colleagues and a team member of mine was, I would say, snatched like this. So hi Moritz, if you're watching, great to have you. Yeah, but another problem is, of course, the rising popularity in machine learning. So not only are there many people that want machine learning experts, but there are also a lot of people that want to get in the field of machine learning. And we get a lot of applications of people from other fields. And yeah, we always have to assess if people can be a good addition for our team. So we basically have to evaluate their potential. So will they be trainable in a short time, or will they take a lot of time for us to train, which we don't have?
Cool.
I think he's watching.
Yeah. No, that's absolutely fine. So Adam, look, if you wanna jump in, same question. Finding the right candidates, cost versus time. What do you think of? What are your considerations when making these types of decisions?
Yeah. So I think right now we're in a transition period in the company to a point where it might make more sense to get people with a little bit more experience in some areas that we just need someone to hit the ground running immediately. But I will say that we've so far had very, very good experiences with taking on people who maybe they first just start in the company as with an internship or something, but they are coming out of the machine learning space, but they really have a creative mindset, and they're willing to take on challenges. They don't get discouraged if the work is hard. So, I mean, we have a team member, and when she first joined, we sort of gave her, and along with, like, she was teamed up with, you know, one or two other people, sort of the most difficult question that we had, that we'd been like dealing with for a couple of months, actually with camera data. And then after like 2-3 months of banging her head against that wall, she was down, and she thought, you know, it wasn't, you know, going that well. And I told her, no, you're doing great, because like we know that it's a really tough question. Like we've been working on this as well for a while, and we can't get a solution. And so then we really try to find people who will be able to, first off, deal with that pressure, because not everyone likes that sort of a pressure, where it's just like, you need to find some sort of a solution. You need to find a solution that meets a certain, like, pretty exacting threshold. And it's not like being a back-end developer, where you can often just Google something and find it on Stack Overflow and boom, you're done. So that's also like, that's the main attribute that we try to select for, regardless of how much experience a person has. Because even if someone's really senior, sometimes the work that we have is just, it's challenging, and you need to be able to sink your teeth into it and potentially come up with a creative workaround. So, yeah.
Nice. Juta, do we have you back yet? Can we hear you?
Yeah, I hope so. Can you hear
Perfect.
me?
Yeah,
Okay.
good.
All right, I'll share my insight on that. So at ML6, actually, we kind of had that transition period that you were talking about, Adam. So I joined 3 years ago and as a junior, and at the time we were lots of juniors trying to build up our expertise. And then we came at a point in the company where we really needed we hired people with more expertise because it was really necessary for us to grow our team. And now, so that, let's say that was a year and a half ago, and now we're actually choosing more for the juniors again, because we now have people that joined like me 3 years ago that have built up their expertise. We also have the expertise that we hired. So now we have a base of like, let's say seniors, people that can do their work, but they also are coaching the new joiners. So lately we've been hiring a lot of people that are either fresh from university or that don't have a lot of experience yet. And we put a lot of efforts into their training. So we also organize lots of internal trainings to really focus on knowledge sharing within our team because we have the expertise in-house. We just need to, we hope to build it up in the juniors as well and to train them.
Excellent. Stefan, onto yourself to complete the round of questions.
Yeah. So we started with, I guess, 5 to 4 very experienced engineers, our core team. So now it's fully different. But what we did is, so we went away from the big areas where machine learning has a strong competition with other companies. So it's Berlin and Munich, where most of the startups are settling down in Germany. So we are directly in the middle. It's near Jena. It's very rural, but we have a strong ecosystem of 8 universities and lots of companies. So we, at the moment, at that point, we got a good mix of well-educated software development guys and also machine learning engineers from the universities. And at the moment, we are, I would say it was the right decision to go that way. Could be that maybe a question to Adam. It's very hard or much harder to find in Munich or Berlin, but not really sure. So this was simply our decision. We went, and now we do a mix of those. So it's simply, it depends. So we get fully different applications. Everyone is fully individual. Everyone has advantages, disadvantages, but at the end, it depends really on the individual and also on the soft skills. So does he fit in the team? Is he willing to make stuff beside work with us and all that things? So yeah.
Excellent. So I do have additional questions I'd love to ask there, but I just try to keep the schedule as much as possible. So I suppose just some personalized questions to every individual. So Laura, I suppose one thing we were speaking about before this was camera systems. I've seen a lot of football computer vision technologies. I guess like when you were starting, the camera systems, they weren't as powerful, the GPUs weren't as powerful. So a lot of it has actually changed in the space of time that you've been working with KickID. What have you noticed the most, I suppose, over the last 1 to 2 years, that in difference that have really helped you to build better models or build better computer vision applications?
Yeah, we actually changed from an RFID system in the beginning of the year to cameras. So that changed a lot. And as you can imagine, RFID is not on par with the idea of making a cheap and available product, which we had. So cameras and the availability and cheapness of cameras is a big part of reaching our goal for us. And this wouldn't have been possible a few years ago, I think. And also important for us is that most people know how to operate a camera as opposed to an RFID system. So we don't have to put that much effort into training people to operate that. So it's more intuitive, even now with the newer generation of tech natives. I mean, every camera, every phone has a camera, everybody has a camera, everybody knows how to operate a camera. So that's easy. And of course, in the future, we would like to use smartphone cameras. But for now, we are using a GoPro, which I think is a good compromise between super expensive expert systems, which have been available for longer, and smartphone cameras, which are now available everywhere, but well, not that standardized. Yeah, and of course, a GoPro is another level of specialization for us, because it's nice to have an action camera on the pitch. It's good for the lighting, and of course, for weather conditions, it's also good for a little bit of rough handling, which can happen on a soccer pitch. And yeah, the readiness of such a system, you can go to just like any tech market and buy such a camera and be ready to use our system. This makes it so much easier for us to develop a product based on this, which would not have been imaginable like 10 years ago. So yeah, we're totally addicted and ready for new developments in this field.
Excellent. So question for you, Stefan. Adam, don't be afraid to jump in, because I know you guys are quite involved in similar topics, but also for everyone watching on Zoom or LinkedIn, feel free to start writing in your questions now, because we will have a short Q&A session at the end before we move into the breakout area. So yeah, so Stefan, what I was getting onto is, you see a lot of trending news about explainable AI, explainability, making a black box a white box. But I suppose a lot of this comes back, and it needs to go a little bit further than just your data specialists, your computer scientists. So when you're building AI products, you mention, and you're very passionate about saying, you need to get the professionals involved, the people who's going to be using this on a day-to-day basis, and the risks of not having them involved to make an explainable, safe AI. Do you want to kind of elaborate on that a little bit more, and what you mean?
Yeah, I guess there's lots of going on in an explainable AI. So what we typically tackle is really the certification standard. So there is some things we need really to understand. So if it comes to a safety critical thing, so and here come the different people together. If it comes to a safety critical thing, then you have to provide someone what state could your system be in future, and it should be determinism, right? So you should say what happens to your car when you drive 5 minutes, or in the next seconds, whatever. It's the intended function. But you have really to say which possible states could there be, and this is really the dilemma. So when you have a machine learning based system, then you have a statistical inference, is this statistical system, and then you cannot say with full determinism this will happen to your system, right? You have there is some percentage uncertainty in your system, and then it's getting really, really hard. And then someone says, okay, show me that your system is safe for 10⁻⁹ driving hours. And then you say, okay, that's a lots of data, so we can calculate in our minds it's 11,000 years of data you simply have to show for a risky function. And that's why it's really important that we bring safety specialists and the machine learning guys together, because the safety specialists, and those are at the moment more people worked for long years in the avionics, in the aerospace, because they did this for years in autopilots and all that stuff. And then this is really important to bring them together and to show that your systems could be safe. And that's where we step on. And we say, okay, we build off sensor redundancy with radars, lidars, very important, and also cameras. And then we put a heterogeneous system composed by AI modules and also deterministic modules. And we build back sources, and we build failback fast passes, which are fully deterministic. And that's the idea. And this is really the challenge today. So it's not how can we explain to a certain level the machine learning. So it's more how can we tackle the certification standard at the moment. And the machine learning itself, it's getting better and better, and explainability is getting better and better, and that's also very important. You can get an SLB for a pure ML-based system. I saw that in the past, but this is really hard to get. So and you have to show safety, and that's why I saw in the past. So the best safety engineers were people who worked a long time in aerospace, then shifting to automotive, to Continental, to BMW or wherever, and they are really good in safety, and they are not coming from the AI. So it's again bringing those guys together and showing the advantages of machine learning and performance, showing the advantages in safety for safety, and then compose a system that fits really the needs of a certification level.
Yeah, I would second that completely. Basically, the only thing that I would say to this topic is that the explainability, as I see it right now, is still at sort of a deterministic inside of perfect laboratory conditions stage. So I've talked with professors who always tell me, oh, the system's deterministic, but when you get into these safety considerations, as Stefan says, you can't do the 10 to the power 9 assertion that it's going to work in that data. So similar to Stefan's approach, we again try to basically complement any individual machine learning model that's doing computer vision, or if with camera, with LiDAR, etc., at sort of a sensor fusion level. Because at a sensor fusion level, then you can start to add in more of those fallbacks and safety checks, and you have a sort of a functional safety plan that meets the industry requirements. So I'll just keep it there, because Stefan already hit all the points.
Nice. So, look, I suppose there's one thing: explainable AI is trending. It's trending in the AI scene, but I think a lot of data scientists, and particularly around computer vision, they underestimate getting ISO certified and how it's basically essential if you want to sell a product into your industry. You guys are both ISO certified. You can tackle this maybe one at a time, or whoever wants to take it first. What steps do you go through to ensure that you're going to get your ISO certification? Who do you involve? How long does it take?
So, shall I start? Okay, this is really what we do at the moment. We work really on RFQs and also on on requirements. And then the long it takes to ensure safety for a specific function it's really based on the intended function itself. So, and this is where SOTIF is all about, and there it starts. And it's also a top-down approach, which works strongly with the customer, and then it needs its time, right? You need an entity who is doing the certification for you. Could be TÜV or other parties who are doing this itself. They going with you all the time. You need educated engineers. They get some specific education in that field as well, and this is the process. But it really depends on the intended function itself. So, and then when it comes to automated driving, then please have a look, like Adam said, on the Twitter account from Elon Musk. So then you get the newest messages. No, but it's really, for us, it's really a top-down approach, very strong with the customer, and really depends on the intended function itself. So there could be a small sentence that really extremely reduces the effort, or the other way around.
Yeah, I think one thing that I was particularly surprised about is you have to say not only specifically what it can do, but also specifically what it cannot do.
Right.
And if your wording is correct, like if you're saying, for example, oh, we build autonomous driving vehicles, we've got a certification for that, you better build autonomous driving vehicles.
Exactly.
Whereas more so, you want to be saying something, we're building an application that will make smarter decisions based on the safest outcome. It's a lot easier to prove in a product as well. So you're your product expectations also have to match up with what you're aiming for.
Right. That's the big challenge that we had, of course, because how do you define driving? It's such a huge topic. So we actually, ironically enough, or just funnily enough, when we were starting down this path of the certification, we actually got in touch with someone who had expertise in the aerospace field. And that guy worked with us to develop the first sort of plan for the system. Like, we already had an idea and we went over it with him. And he said, this looks like it should be able to be certified. That was sort of his opinion. And then sort of as Stefan said, you had to then meet with, in our case, it was the TÜV. And we were then, like, we've started the process then with them, talking with them to find out more about how some of these standards that are still evolving. So like I think when we started the 21448, the PASS-SOTIF thing, it wasn't even done. Now it's sort of, it's finished, or it will be finished very soon. And if I remember correctly, the last time I took a look at it, it was sort of supposed to be up to like level 3 autonomous driving. But if you want to do level 4 autonomous driving, where of course the human has even less of a role in terms of the vehicle, which is also where it becomes most interesting from like a business perspective, because you can sort of eliminate some costs for human drivers in applications like, let's say, logistics or robo-taxis or whatever. Even there's still a little bit of a gray zone. So it's getting clearer and clearer. Germany's also like now really pushing with the laws so that the legal structure is becoming clear. And then finally for us, it's now been very much about defining this scope, this ODD that we are in, so that, as you say, we don't oversell the product, but we definitely can deliver everything that we've put into the plan, because we're in the certification process, so we don't have it just yet, but eventually we will literally be going to like a test field, and the certifier will systematically basically just like break the system, turn things off, and see if it behaves the way it should. So, yeah.
Nice, very good. Thanks, Adam. So Juta.
One thing from my side, so we have, I guess, a different approach to market. So what we really do, we do not do the full system architecture as a complete product. So we deliver small modules to customers and closely work with the customers as partners to deploy a specific function in real world. So this is the thing. I have a small demo if I can show this. That really.
Go ahead, yeah.
What we did here with a partner was simply to visualize the safety thing and how important the sensor fusion is now. This is really a small function, but this is here at the moment a thing we did with a partner, and here the scope was a free space detection, right? And free space detection, and this is simply a demo how what we show also in our decks to customers. So you see here, right? I have to go back again. Sorry for that. We have here one pass really, and you see here it's a driving scene. It doesn't look very well, but this is another part here. You see here fully geometrical pass scene on the LiDAR sensor, and this LiDAR sensor creates here with the algorithm beyond some 3D boxes around cars, some free space in front of car. It detects some street and all that stuff, but it's everything fully deterministic. It's rule based, right? And now we see something happens if we compose that with the semantic segmentation, we call that, and we can create some classes on our objects. We see what is street and whatever else. But we see here, and that's what we want to show, we have a very bad deep learning model. We call it lumber truck. We see here the lumber truck. It's a truck in front of us that really carries some lumber. And the lumber is detected because of a bad model as wood, because it wasn't in training set. So it's detected as wood, and it's going into the background because it's vegetation. We see it here. And this is very, very strong and very, very, very risky because this lumber has an extreme overlength. So 3 meters overlength. Well, again, I made some mistake. Sorry for that. It has an extreme overlength. I go here again. And we see, if we only look on the deep learning module, I make pause here. if we look only on the deep learning module, we see, okay, it's going to the background, but our safety pass, and this is at this point here for the free space detection, it's a LiDAR, and we see the 3D box detection is confident, it's deterministic, so it detects the overlength of the lumber truck as lumber truck, but with the real geometrical size, and at the end, the free space detection on the street is really right shape. So this system is safe towards some safety standard. This is just a demo, but it just want to visualize what we are talking about at the moment, and where some of the deep learning modules really fail because something isn't in the training set, you have bad data, and then the lumber on the truck goes to the background, is vegetation, what is per definition not wrong, but it's not safe. This is what I wanted to show here.
Excellent. Thanks, Stefan. Really cool demo. Juta, do we have you back? Can we ask you one penultimate question before we go to Q&A? Excellent. So you actually opened it up at the start. You mentioned you were working on some cool GAN projects. I suppose my question to you is I know you do like research labs of new technologies in ML6, and I would have gathered you were doing something around the area and the topic of GANs. What sort of applications are you using for GANs, and what applications do you think it will also be able to have in computer vision as an industry? Will we see synthetic data sets, or I suppose what's actual capabilities that we will see?
Yes, so the reason that I chose to talk about GANs is because I actually find it really interesting. So I wanted to come back to the topics of how do you hire people? Like we often ask, what makes you enthusiastic about ML? And then my answer is GANs. Like I really find it very cool that you can generate data out of basically a random noise vector. So people then often think like, okay, GANs, this brings us immediately to deepfakes, and there's not really any, or people might think that it cannot be useful at all. What I actually worked.
Your sound is still kind of pitching in and out. Is your other headset available, do you think?
I have it on.
Oh.
Let me try. Can you hear me?
Yes.
Better?
Yes.
All right, so maybe let me rephrase a bit what I was saying. So I was saying that GANs, people often think like immediately about deepfakes, so where you can create fake videos of people. And I wanted to talk about GANs because there are more use cases to it than just these funny use cases. So one of the projects that I worked on last year was, for example, a project where we created saliency heat maps. So you start from an image, then you scale it down to a vector, and then you sample it up again so that you create a saliency map, so you predict where the people will look in the image. And we actually, so you can train that as a regular neural network without using GANs, but from research that we read, you can see that it actually, you get more realistic results if you train it with a GAN. So that's one of the use cases. And more recently, another use case is to use this as an input for a newspaper. So in a newspaper, they try to do automatic editing of their articles. So one side is text, but the other side is also to do automatic cropping of their images. So this goes hand in hand with the saliency use case, where you can predict, okay, this is the most important part of the image, and then based on that information, you can then decide where to crop your image. And to answer the second part of your question, so we do a lot of research with it as well. And then one of the examples of what it can be used for as well is, for example, to generate training data, because we work a lot on this kind of research, and one of the issues that arises quickly is we don't have any trainee data. So that's also can be an interesting use case.
Perfect. Thanks, Juta. I think maybe me and you could do maybe a follow-up on that as well. Maybe with some better audio quality. Maybe we could do a little YouTube video if you'd be open to it as well, of course. Has anyone got any questions before we go into our breakout room from the audience? If you want to type them into chat, we can answer them live. Does any of the panelists have any questions for the other panelists?
No, but I would really like to hear more about the GANs. So looking forward to that YouTube video.
Cool. I do have a question come in from Lisa in the audience. She said, if you had to name one thing that elevated your career in machine learning the most, what would it be? And do you have a practical tip for people at the beginning of their machine learning career?
So I have a tip. So we said it always. So it's from in the field where we are. So it's a strong software development skills are really important, and not for us C++. So this is very important to be really good at with patterns, with all that stuff we know from good software development skills. So there is, I guess, a big market to do embedded deployment of next gen technology, but I really want to get people really familiar with that. So this is important from my point of view, and do not treat it as a bad asset going around. So, but this is the fundamental thing. So from in the computer vision deployment, but it's not in every market. So.
Cool. Anyone else want to give a quick answer before we move over to the breakout room?
So this might not be applying, but I started out as a working student, and I really focused on getting jobs that solely focused on machine learning, deep learning, so on the stuff that I wanted to learn. And yeah, I think the tip is to really learn, try to read as much as you can about the topic, try to be passionate about it, read conferences, just try to learn a lot of techniques, and don't worry too much about not understanding it. Comes with the time.
Excellent. Well, look, I think that's going to just be us running on time. We've got to switch over to the breakout room now. But look, I want to thank everyone who's attended. I want to thank Rachel for being our body sign language interpreter. Laura, Adam, Stefan, and Juta, thank you for being my panelists. I really appreciate it. So for everyone who may have caught the end of this, this event was recorded. It will be going live on LinkedIn, YouTube, maybe in the next 1 or 2 days. And we'll also have a white paper to follow up. But everyone, thanks for attending, and have a great evening.
Thank you.
Bye.
Thanks.